Okay, this is lesson 1.1, dividing a polynomial by a binomial. So let's talk about the characteristics of a polynomial. A polynomial is a function composed of variables, constants, and coefficients, right? We've covered all this before. So for instance, this first one here, 3x plus 5, that is a binomial, right? That is a binomial, but it's still a polynomial, right? We got the variable x, we got the 3 as the coefficient, right? We got the 5 as the constant. And then we have this one, this x squared plus 2x minus 1. It's trinomial. And we have x with a variable with an exponent there. We have our coefficient 2, our variable x again, and our constant -1. And even 6 can be considered a monomial or a constant in this case. So degree of a polynomial, right here, degree of a polynomial is the exponent of the highest power. So for instance, this one back up here, this x squared one here, the x squared, so that is a degree of 2 because of the square in there. Leading coefficient, remember in front of the variable, the coefficient is whatever the variable is, sorry, whatever the number is in front of the variable. The leading coefficient is the one with the highest power. So for instance, this x squared plus 2x minus 1, it's in descending order. What's in front of that x squared? Well, it's a 1, so that's the leading coefficient. And we normally write them in descending order. Okay, so that is going to help us look at what the main graphing pieces are for this stuff. And the first three you covered back in 9, 10, and 11. So this first one here, degree of 0 constant function, this would be like a horizontal line. You can see it right here. So this is y equals 3. Then we did linear functions. This is like y equals mx plus b. It's an odd degree because above the x, right, it has a number of intercepts as 1. It crosses the x-axis at one point. Degree of 2. So this would be a quadratic like the x squared. And you remember you can have different x-intercepts. You can have 0, 1, or 2. Remember we talked about that was the discriminant, right? Whether it was positive or negative or 0, right? We could have this parabola above the x-axis. We could have it cutting through the x-axis like this, or it could touch the x-axis at one point. The three new ones we're going to talk about in 12 are cubic, quartic, and quintic. So this is x cubes, x fours, x fives, okay? So this one, if you look, kind of has a nice squiggle to it. Quartic is kind of like a W, and a quintic is like the cubic, but with an extra bump in it. Now, there's a couple of things you should look at. So this can have, back to the cubic, can have 1, 2, or 3 x-intercepts. Quartic can have 0, 1, 2, 3, or 4. And a quintic could have 1, 2, 3, 4, or 5. And something that's kind of interesting is you can look at the odd and even degrees. So back up here on the quadratic, this is an even degree. And if you notice, both the arrows go the same direction. They can either go up or they could go down to whether it's positive or negative. Cubic, you'll notice that the arrows go different directions, one up, one down. And again, depending if it's positive or negative, they go different directions. We'll get more into this later on. This is just an intro to it. Quartic, since it's an even degree, they both either go up or they're either both going to go down. Quintic, opposite, either up and down or down and up, right? You'll see that as we go along. So you can look at some of the key components here, like the domain and the range and all that interesting stuff, but more of it's going to come. Okay, so the main part of 1.1 is we are going to start doing division. And you learned a long time ago, long division, right? Setting it up. I'm going to show you how to do long division when it comes to this. This is a polynomial divided by a binomial. I'll show you the long division, and then I'm going to show you a shortcut called synthetic division, and that's the one we're going to use over and over in the future, because what's going to happen is I'm going to give you like an x to the 5 somehow, and you're going to have to break it down into all the different binomials, which would happen to be the x-intercept, so you can graph this. Okay, so let's look at this one here. So what we do is we have our divisor, our x minus 1, and our dividend underneath here. We put our bar in here, and then what we do is we look at, so this first one here, this one right here, I need to take whatever I put up here, multiply it by x, and get 2x cubed, because what's going to happen is I need that 2x cubed underneath here, so when I subtract them, I end up with my 0. So I put my 2x cubed, and I times it by x, and I get my 2x squared, and I times it by x, I get my 2x cubed. But it's a binomial, so you have to realize it's 2x squared also times -1, which gives us our negative 2x squared. Put our line here and do subtracting. Now you got to be careful. So this is 2x cubed minus 2x cubed. That's 0. It's gone. Now careful on this next part. This is negative 1x squared minus negative 2x squared. So it'd be like this, -1 minus -2. Don't get caught up in the math, right? So that would be positive 1x squared. Okay. Then what we do is we bring down the next, in this case, variable. We drop our x. We put it here. So we have a nice 1x squared plus x. We're going to put something up the top here, and in this case, we're going to times it by x. So x times x is x squared. Yeah, those are going to be awesome when we subtract them. They're going to cancel out. But don't forget, x times -1 is negative x. Draw our line. So the first two disappear. So now we have positive x minus negative x. Again, positive x minus negative x, which is 2x. Bring down the negative 4. We need to stick something up the top here that when we times it by x, we get to 2x. So we use a 2. 2 times x is 2x right there. And don't forget, 2 times negative 1 is negative 2. And we're subtracting these two. So we end up with a remainder of negative 2. So they're not always going to work. Now, that is a long process. And you need to know how to do that because it really helps you with stuff later on. But this is only an x cubed. We can do x4s and x5s, and it's just going to take a while. So we're going to do synthetic division. So when we do synthetic division, we only worry about the coefficients of the dividend. Okay, so look back up here, the coefficients. We have a 2, we have a negative 1, we have a positive 1, we have a negative 4. So they go right there, 2, negative 1, positive 1, negative 4. Then, opposite of constant in the divisor. So let's look at the divisor. The divisor is x minus 1. What number, x minus 1, what number do we plug in there to make it equal to 0, or it's the opposite? Well, we're going to plug in a positive 1. So that is what we put out the front, right? So if you see a x minus 1, you're going to put a 1 in the front. If it was an x plus 1, you'd put a negative 1 out the front. Okay. Now, here's the process, and you can stop and go back and do this again. First thing we do is we bring down the first one. Just drop the 2. Then we multiply by the constant. So 1 times 2 is 2. Okay, so 1 times 2 is 2. Then, negative 1 and 2, we add them together. We get positive 1. Right? Then we go 1 times 1 is 1. 1 times 1 is 1. And then we go add these together. 1 plus 1 is 2, right there. 1 times 2 is 2. 1 times 2 is 2. And we add those together and we get negative 2. Okay. Now, if you look, we end up with negative 2. What did we end up with here? Oh, negative 2. Oh, that's cool. That works. So that's a remainder of 2. Now, the next part is this part underneath here, right? What does that become? Well, this wasn't originally an x cubed, so we're doing 1 less than it. So this is going to be an x squared. So you just look at the coefficients. So this 2 is going to be 2x squared plus 1x plus 2 with a remainder of negative 2. And that's exactly the same answer as we got above. So synthetic division is really, really fast, but you still have to know where we're coming from with long division. Okay, flip the page. Let's try another example. So this one here, we have x to the 4 minus 2x squared minus 1 divided by x minus 3. Now, the problem with this one is, if you look, we have x to the 4. Well, we're missing x to the 3, and we're also missing an x. So if you do long division, you need to fill those in. So we have x to the 4. Well, we don't have an x cubed, so we just put a 0. Minus 2x squared, we don't have an x, so we put a 0, and then minus 1. And then we do our x minus 3 out the front. Now, this alone right there would be very difficult to do. You still need to practice it, but let's see synthetic division. So we deal with the coefficients. So 1, 0, negative 2, 0, negative 1. And you can see them right there. 1, 0, negative 2, 0, negative 1. Now, this one here, what number do we plug in there to make that equal to 0? Well, we plug in a positive 3. So the positive 3 goes at the front. And then the pattern just continues. Bring the 1 down. 3 times 1 is 3. Add the 0 and the 3, we get a 3. 3 times 3 is 9. We add the negative 2 and the 9, which is 7. 3 times 7 is 21. 0 plus 21 is 21. 3 times 21 is 63. Negative 1 plus 63 is 62. Okay, so there it is right there. Now, if you look, this was an x to the 4. So when we break this down, it's going to be x to the 3, right? There's the 1, plus 3x squared, plus 7x, plus 21 with a remainder of 62. Now, you can write it like that, but there's a better way to write it, and that's here. So you write all this out the same, the x3 plus 3x squared plus 7x plus 21, but you write plus 62, and if this was negative, it would be negative 62, divided by x minus 3, because that's what we were dividing by way up here, right? This is the more preferred way. So this is the way you should be writing it from, well, as you go along through this one. Okay? Let's do another example. Last example on the page here. Okay, so this one, this one's really tricky. So we got 6x cubed plus x squared plus 13x plus 12. So nice, we're not missing any, we don't need to put any zeros in there, but look what we're dividing it by. 3x plus 2. Oh, cool. We can't do that. Normally, when we do this, there is no coefficient of x. So it'd be like x minus 2 or x plus 1 or something like that. Well, the first thing we got to do is we got to factor out a 3. When we factor out a 3, that's the same as multiplying it by, that's what that means, multiplying it by a third. So let's look at this. So let's write it down. So 6x cubed plus x squared, excuse me, plus 13x plus 12 divided by 3x plus 2. Now, on the bottom, we need to take out a 3. We're going to factor out a 3. So that's easy. 3x divided by 3 is just x, but 2 divided by 3 is 2/3. We're going to be dealing with a fraction. Oh, well. Now, what did we say, though? The same as factoring out a 3 is the same as multiplying it by 1/3. So instead of that 3 there, we can put our 1/3 out the front. Okay? Now, what we're left with in the brackets is what we're going to work with. But then here's the key thing. So what we do is we divide by x plus 2/3. But then when we're finally done, we have to take a third out of the answer. You'll see that. It's coming later on. Okay, so let's set this up. So look at our coefficients. We've got a 6, a 1, a 13, and a 12. There it is. A 6, a 1, a 13, and a 12. Now, it's x plus 2/3. So what number would you plug into there to make it equal to 0? Well, that's negative 2/3. Oh, okay. Well, that's not bad. We're going to work with a fraction, but it's not bad. Let's do the math now. Bring down the 6. Then you multiply 6 by negative 2/3, right? So negative 2/3 times 6 gives us negative 4. Then we add these together. 1 plus negative 4 is negative 3. Awesome. Then we go negative 2/3 times negative 3. Negative times negative is positive. Works out to be 2. So 13 plus 2 is 15. Negative 2/3 times 15 is negative 10. 12 plus negative 10 is 2. So remainder worked out really nice in this case. So again, this was an x cubed, right? So our next one down is going to be an x squared. So 6x squared minus 3x plus 15 plus 2 over x plus 2/3. Now, don't forget what's out the front there. We got a third out the front, so we have to distribute that third to everything. Okay, well, that's easy, right? 6 divided by 3 is 2, so 2x squared. Negative 3x divided by 3 is our negative x. 15 divided by 1/3 is 5. And when we multiply this by 1/3, we end up with our 3x plus 2 again. Note that the bottom is the same as the start. Like this thing right here is exactly the same as what we had back up here, the 3x plus 2. So it looks complicated, but you just have to remember to pull out the factor to make it just x by itself. And again, if you're struggling with this, just go back and watch the video again. Like you can slow it down and stop it and do that. And if not, you can just ask me questions. Okay, so that was 1.1, dividing a polynomial by a binomial.